What if the strongest influence on slowing visible aging is not a topical product, not a medical procedure, and not a drug development, but something as simple as a food eaten quietly at the end of the day? For a long time, people have been told that fine lines, thinning skin, and loss of firmness are unavoidable marks of time written into human biology. Yet that idea may be incomplete. Aging in the skin may not be only a passive decline, but an ongoing interaction between cellular systems and the environment they operate in. In this view, the skin is not just a surface showing age. It is part of a living communication network. At night, that system changes its behavior. The most active phase of skin repair does not occur during daytime exposure, but during sleep. In the silent hours of rest, the body shifts into maintenance mode. DNA repair activity increases. Collagen production rises. Circulation patterns adjust. Cells begin a decision-making process focused on either rebuilding tissue or conserving energy. During this phase, biological repair systems become more active. Research has suggested that skin cell division can nearly double overnight, particularly in the window between 11 p.m. and 4 a.m., as reported in studies associated with the Journal of Investigative Dermatology. However, this repair state is not guaranteed. It depends on biochemical signaling. The body requires specific cues to commit resources toward regeneration instead of simple maintenance. One of the key regulators involved in this process is melatonin. Although commonly known for its role in sleep regulation, melatonin also functions as a cellular signaling molecule. It participates in antioxidant defense and helps coordinate repair activity at the cellular level. Research from institutions including Harvard, the National Institutes of Health, and the University of Barcelona has explored how compounds found in certain nuts, including polyphenols, omega-based fatty acids, and trace nutrients, may interact with biological pathways connected to aging and skin maintenance. Among these foods, one nut has drawn particular attention. Before identifying it, it is important to understand the foundation of the process. The skin is the largest organ in the human body. It reflects internal metabolic state, immune balance, and overall physiological resilience. Because of this, skin aging is closely linked to internal biological aging. This raises a central question. Are daily dietary patterns supporting regeneration or contributing to faster decline? In the evening hours, the body enters a coordinated repair state. Damaged proteins are broken down. DNA structures undergo correction. New cellular components are assembled. Skin tissue becomes especially active during this period of recovery. But this system depends heavily on internal signaling balance. Melatonin is one of the key regulators that supports this nightly transition. It acts not only as a sleep-related compound, but also as a potent antioxidant and a timing signal for cellular restoration processes. At this point, attention turns to walnuts. Research conducted at the University of Texas Health Science Center has identified that walnuts contain measurable levels of melatonin that can be absorbed by the human body. This means they may contribute to circulating melatonin levels after consumption, not through synthetic delivery, but through natural dietary intake aligned with circadian rhythms. When eaten in small amounts during the evening, walnuts introduce bioactive compounds that may support the body's transition into nighttime repair mode. Alongside melatonin, walnuts also contain magnesium. This mineral is important for activating the parasympathetic nervous system, which is responsible for rest-oriented physiological states. Without adequate magnesium, it becomes more difficult for the body to fully enter deep restorative sleep, where regeneration processes are most efficient. In combination, these effects create a layered influence. Melatonin helps guide timing. Magnesium supports depth of rest. Together, they reinforce the conditions needed for nighttime biological repair. Many people notice that after a night of deep, uninterrupted sleep, their skin appears more even, more luminous, and more refreshed. This observation aligns with known biological activity, where restoration processes are most active during sleep cycles. From this perspective, aging is not purely a fixed downward path. It can be influenced through consistent biological inputs, including nutrition and sleep behavior. A simple evening intake of walnuts may support systems involved in repair, but their influence extends further into structural skin biology. Regeneration is not only about recovery from damage. It is also about rebuilding structural strength. The visible qualities of youthful skin, including firmness and elasticity, are largely determined by the integrity of collagen networks beneath the surface. Collagen is continuously broken down and rebuilt. It is not simply lost over time, but becomes less efficiently produced as aging progresses. This shift is linked to fibroblasts, the cells responsible for generating collagen. These cells function as the structural builders of skin tissue. In early life, fibroblasts are highly active and responsive. Over time, exposure to oxidative stress, chronic inflammation, and nutritional depletion reduces their efficiency. The cells remain present, but their activity slows due to changes in their environment. This leads to an important question. How can the internal conditions that support fibroblast activity be improved so that collagen production remains efficient later in life? Walnuts are introduced again as part of this discussion, as their nutrient profile may contribute to supporting the biological environment in which these cells operate. Walnuts are recognized as one of the most concentrated plant-based sources of alpha-linolenic acid, known as ALA, which is a form of omega-3 fatty acid. Omega-3 compounds are often associated with cardiovascular function, but their influence on skin biology extends much further. Findings published in the American Journal of Clinical Nutrition indicate that omega-3 fatty acids can affect fibroblast behavior. These cells are involved in building collagen, and omega-3 intake has been associated with supporting their activity while also reducing the enzymes responsible for collagen degradation. These enzymes are commonly referred to as matrix metalloproteinases, or MMPs. One way to understand this process is to separate it into two opposing forces. Collagen creation represents construction. Collagen breakdown represents demolition. With aging, the balance often shifts toward faster breakdown compared to rebuilding. Omega-3 fatty acids help adjust this balance. They do not completely stop breakdown, but they support a condition where rebuilding can keep up with loss. Walnuts also contain copper, a trace mineral that plays an important role in stabilizing collagen structure. Copper is required for proper cross-linking of collagen fibers. Without enough copper, newly formed collagen lacks strength, similar to a framework built without secure joints. This creates a layered biological effect. Fibroblasts are supported in their activity through omega-3 intake. Structural integrity is reinforced through copper. The relationship between synthesis and breakdown becomes more balanced. These effects are not dependent on complex interventions. They can be influenced by consistent dietary intake over time. This raises a broader question about perspective. Skin health is often approached through external application, yet the biological construction of skin originates internally. The skin is not built from the outside inward, it is constructed from the inside outward. Nutrients delivered through the bloodstream shape every layer, every fiber, and every structural component over time. This understanding shifts the focus from surface treatment alone to internal biological support. It also highlights an important principle. The body already contains the biological systems required for youthful skin structure. These systems do not need to be replaced. They need to be properly supported. Aging is not always a dramatic event. Many of its processes occur gradually and without clear sensation. Among the most influential of these hidden processes is chronic low-level inflammation. This form of inflammation does not present with visible injury or immediate discomfort. It operates silently, continuously influencing cellular behavior beneath awareness. In longevity research, this condition is often described as inflammaging, a persistent inflammatory state linked to accelerated biological aging, including visible changes in the skin. Inflammation does more than directly damage tissue. It alters how cells function. It can reduce fibroblast activity, increase collagen-degrading enzymes, and disturb the balance between repair and breakdown processes. It also shifts the body into a protective mode, where regeneration is no longer prioritized. Under these conditions, even adequate sleep and nutrition may not fully support repair because the system remains in a defensive state. For this reason, addressing inflammation becomes a fundamental factor in aging biology rather than a secondary concern. Walnuts play a role in this context due to their polyphenol content. These compounds act as bioactive signaling molecules within the body. They influence pathways that regulate inflammatory responses rather than simply neutralizing oxidative stress. One of the central regulatory systems involved is NF-kappa B, a protein complex that functions as a control switch for inflammatory activity. When NF-kappa B is activated, it promotes the expression of genes that produce inflammatory cytokines, which sustain immune signaling and inflammatory response. Research published in journals such as Nutrients and the Journal of Nutrition has shown that compounds found in walnuts, including L-glutathione and other polyphenols, may reduce activation of NF-kappa B. This does not eliminate inflammation entirely, since inflammation is necessary in appropriate contexts. Instead, it helps restore equilibrium in inflammatory signaling. A useful way to visualize this is through a city model. Inflammation resembles an ongoing emergency state within a city. Sirens remain active, resources are redirected, and systems operate under constant alert. In that condition, construction slows, maintenance is delayed, and long-term development is paused. When the emergency response decreases, normal function returns. Infrastructure can be repaired, systems are restored, and development resumes. The skin behaves in a similar way. When inflammatory pressure decreases, collagen breakdown slows, repair activity increases, and cellular communication becomes more efficient. Over time, these changes accumulate into visible differences. This progression is gradual rather than immediate. A key question arises from this understanding. How many daily patterns, including diet, stress exposure, and sleep disruption, contribute quietly to maintaining a low-level inflammatory state without awareness? Aging can be understood as the long-term accumulation of these subtle biological signals. Walnuts do not produce instant visible reversal of aging. Instead, they influence the direction of biological signaling over time, gradually shifting the system toward a state where repair processes are more active. At this point, attention turns to another essential factor in skin health. Collagen integrity depends not only on production and inflammation balance, but also on blood flow and nutrient delivery. The skin is supported by a dense network of microscopic blood vessels known as the microvascular system. This system supplies oxygen, nutrients, immune factors, and repair signals directly to skin tissue. With aging, this network gradually becomes less efficient. Vessel flexibility decreases, circulation slows, and capillary density may decline. As a result, skin can appear less vibrant, slower to heal, and more structurally fragile. This process is often subtle and develops over time rather than appearing suddenly. Before visible aging becomes apparent, reduced nourishment at the microvascular level is often already present. This means skin aging is not only a surface change, but also a circulation-related process. Within vascular biology, a key component of this system is the endothelium. The endothelium is a thin cellular layer lining blood vessels and functions as a regulatory interface for vascular behavior. It controls vessel dilation, blood flow distribution, and participates in inflammatory signaling regulation. When endothelial function is healthy, blood vessels respond dynamically to the body's needs, supporting efficient delivery of nutrients and oxygen to tissues such as the skin. When blood vessels function properly, they expand in response to the body's needs, delivering nutrients efficiently throughout the system. When this function weakens, circulation becomes slower, less flexible, and less responsive overall. This is the point where nutrition from whole foods, especially nuts, becomes biologically significant. Walnuts have been widely studied for their effects on cardiovascular function, particularly in relation to endothelial health. Research associated with the Harvard T.H. Chan School of Public Health and findings published in Circulation suggests that consistent walnut intake is linked with improved endothelial performance and greater nitric oxide availability. Nitric oxide is a signaling molecule that allows blood vessels to relax and widen. This matters directly for the skin because nitric oxide acts as a vascular communication system. When levels are balanced, blood vessels maintain flexibility, which enhances microcirculation throughout the body. When microcirculation improves, multiple processes at the skin level begin to shift. Oxygen delivery becomes more efficient, nutrient transport increases, waste removal becomes more effective, cellular repair activity during sleep becomes more active. The skin can be compared to a living garden. Even nutrient-rich soil cannot produce healthy growth without proper water flow. Blood circulation functions as that irrigation system. Through a combination of alpha-linolenic acid omega-3 content, L-arginine-related precursors, and antioxidant compounds, walnuts help support this internal distribution network. A simple observation makes this easier to understand. After restful sleep, good hydration, or even light physical movement such as walking outdoors, the skin often appears more refreshed and more vibrant. This is circulation in action. Now imagine that condition not as an occasional event, but as a consistently supported state from within the body. Small daily inputs gradually influence how biological systems function over time. Not through sudden transformation, but through continuous reinforcement of core processes that regulate skin behavior. At a deeper biological level, skin aging is not only driven by accumulated damage, it is also influenced by reduced delivery efficiency. Over time, the body becomes less effective at supplying cells with what they need to function optimally. Supporting vascular function therefore means more than improving appearance. It helps restore communication between biological systems. A key question arises from this understanding. If every skin cell depends on a continuous supply of oxygen and nutrients, what happens when that supply begins to slow down? And what would it mean if even partial restoration of youthful circulation could be achieved? In biological systems, small improvements in blood flow can produce disproportionately large functional changes. This is where consistency becomes more important than intensity. Repeated intake of nutrient-dense foods over time can gradually improve how efficiently the body distributes resources, not as a concept, but as measurable physiological function. There is also another layer of aging that operates continuously. It does not depend on age milestones. It occurs in every cell, at every moment. This process is known as oxidative stress. Oxidative stress is not an external threat. It is a natural byproduct of energy production, where oxygen and nutrients are converted into usable cellular energy. During this process, unstable molecules called free radicals are formed. These molecules lack stability and attempt to restore balance by taking electrons from nearby structures, including proteins, lipids, and DNA. Over time, this creates small but repeated structural damage within skin tissue. This damage is especially important because it affects two key structural proteins: collagen, responsible for firmness, and elastin, responsible for flexibility. When damage occurs faster than repair, visible signs of aging begin to appear, including fine lines, reduced elasticity, and thinner skin texture. However, oxidative stress is not only about damage. It is fundamentally about imbalance. The body already has internal antioxidant systems designed to neutralize free radicals. These include glutathione, superoxide dismutase, and catalase, which function as protective mechanisms within cells. Problems arise when lifestyle factors such as chronic stress, insufficient sleep, environmental exposure, and processed food consumption increase free radical production beyond what the body can neutralize. At that point, the balance shifts toward greater damage and reduced repair efficiency, accelerating visible aging. This is where walnuts become biologically relevant again. Walnuts contain high levels of polyphenols and vitamin E, which function through complementary mechanisms. Vitamin E is fat-soluble and integrates into cell membranes, where it protects lipid structures from oxidative chain reactions. Polyphenols act differently. They influence cellular signaling pathways and support the activity of the body's own antioxidant defense systems, rather than only neutralizing free radicals directly. This combination strengthens multiple layers of protection within the body at the same time. A simple analogy helps explain this process. Skin cells can be viewed as a constantly active city. Free radicals resemble sparks generated by ongoing activity. In small amounts, they are manageable. But when production increases, those sparks can develop into widespread damage. Antioxidants function as response systems that extinguish these sparks before they spread. When these defenses are strong and well supported, damage remains controlled. When they are insufficient, structural decline gradually increases. Oxidative stress therefore represents a mismatch between damage generation and defensive capacity. Unlike isolated supplements, walnuts provide a network of protective compounds that operate together rather than independently. This creates layered biological support rather than a single isolated effect. Since collagen breakdown results from repeated microdamage over time, even modest and sustained reductions in oxidative stress can influence the overall direction of skin aging. A key question follows from this. If aging is primarily the accumulation of microscopic damage that is not immediately visible, what would happen if that damage were consistently reduced every day over a long period of time? Not instantly, but gradually, like adjusting the source of a river. Biological systems respond to repeated signals over time rather than sudden changes. At the same time, skin aging is not a passive process. It continuously responds to internal balance between repair activity and damage accumulation. This means the trajectory of aging is influenced moment by physiological conditions within the body. This leads to a deeper understanding. Biology is not only reacting to external conditions, it is continuously interpreting and recording them at a cellular level. And in that process, the body is constantly reshaping its own state based on those signals. CTA. If this perspective on how nutrition, circulation, and cellular balance influence skin aging resonates with you, continue exploring this topic and apply these insights consistently in your daily routine. Please leave your thoughts about this content in the comments below. Thanks for watching. See you in the next one.